Hello everyone, welcome to Smart Interviews YouTube channel. This is Vinay. Today we are going to discuss CodeChef Starters 163 contest problems. Let's get started. The problem statement is Chef needs $8 to buy himself a new pair of socks for Christmas. If he has X dollars saved up and his parents give him an additional Y dollars, will Chef be able to buy new socks or not? So the cost of new pair of socks is $8 and the chef has X dollars with him and his parents give him additional Y dollars. So you have to check whether you can able to buy the new socks or not. So in the input format you will be having three values A, X and Y. So nothing but the amount of money, nothing but X plus Y dollars. If it is greater than or equals to A, he can able to buy the socks, else he cannot buy the socks. Let's write the code for it. So A comma X comma Y is equals to you need to check if A is less than or equals to X plus Y. X is nothing but the amount of dollars he has and Y is nothing but the amount of money his parents give. Let's run it. Yes, let's submit it. It got accepted. Moving to the next problem. The problem statement is you are given two integers n and k. Your task is to determine if there exists a binary string s of length n such that s1 plus s2 plus s3 and so on up to sn is equals to k. That is, the sum of all the digits of the string equals to k, and the second condition is s of I is not equals to s of I plus 1. So that means no two adjacent digits are equal. So in the process of constructing this binary string, which consists of only zeros and ones, you cannot place adjacent zeros or you cannot place adjacent ones. And if you see the input format, the first line of input contains a single integer t denoting the number of test cases. And for each test case, you are having two integers n and k, where n is nothing but the length of the string and k is nothing but the sum of all the digits in the string should be equals to k. And the output format is, for each test case, you have to check whether you can able to construct the valid binary string or not. If you can able to construct, then you have to print yes, else you have to print no. And if you see the constraints, t can go up to 1 to 100 and n can go up to 1 to 100 and k can go up to 0 to 100. Let's see the sample test cases. So basically the problem statement here is you'll be given n value and the k value. You have to construct a binary string which is of length n. So based on the second condition, we'll try to construct the binary string for the first test case. So in the first test case, n is equals to 5 and k is equals to 2. So based on the second condition, nothing but no two adjacent digits are equal. So how many valid strings we can construct? It should be of size 5. So basically either you can start with 0 or you can start with 1. So if I start placing with zeros, you can place 0, 1, 0, 1 and 0. So this is one valid string which satisfies the second condition. Also you can construct 1, 0, 1, 0 and 1. This is also another valid string which satisfies only the second condition. So if you want to print yes, you also need to satisfy one more condition, that any one of the string sum should be equals to k. So if you consider the sum of the first string, you'll get 2 here, and the sum of all the digits in the second string is 3. So if you observe here, you can able to construct one valid string whose sum is equals to 2. So for the first test case, you can print yes. What about the second test case? Your n is 7 and k is 5. So basically, we understood that you can construct only two valid strings which satisfy the second condition. That is starting with 0 and the second one is starting with 1. So let's try to construct here a string of length 7. So 1 is starting with 0. So 0, 1, 0, 1, 0, 1 and 0. And what's another possible string starting with 1? So 1, 0, 1, 0, 1, 0 and 1. So what is the sum of all the digits in the first string? It is 3. What is the sum of all the digits in the second string? It is 4. So can you able to construct a string of length n such that sum of all the digits is equals to 5? No. The two possible strings that we can construct are the sum is 3 and the sum is 4. So for that second test case, the output is no. I hope you guys understood the problem statement. Pause the video and think for all the possible solutions. Okay, let's see. So basically you can validate the solution based on the two conditions. The first condition is, we'll take one example and see. Let's say if you are given n equals to 6, nothing but you are telling that you need to construct a binary string of length 6. So can you tell me what are all the possible sums you can achieve of length 6 which satisfy the second condition? So nothing but let's try to construct the string and understand. Starting with 0, you'll get 0, 1, 0, 1, 0. Starting with 1, you'll get 1, 0, 1, 0 and 1, 0. So for the first string, you can get the sum as 3. For the second string, you can get the sum as 3 again. So if you observe here, if your string length is even, what are all the possible sums you can achieve by satisfying the second condition? Simple. How can you relate this sum with respect to n value? Nothing but n by 2. So if your n value is 6, then all the possible sums will be n by 2, nothing but 3, if the length is even. If n is equals to 8, what are all the possible sums you can achieve with satisfying the second condition? Nothing but n by 2, you'll get 4. Hope you understood. So if n is even, if n by 2 is equals to k, then we'll print yes, else we'll print no. Clear? Now coming to n is odd. So we have already traced where n is equals to odd. So when your n is 5, what are all the possible sums you can achieve? You can achieve 2 and 3. So how can you relate this n with respect to these sums? Simple. 2 is nothing but n by 2, integer division, nothing but 5 by 2. And how will you get this 3? We'll write 5 by 2, integer division, you'll get 2. And how will you get 3? 5 by 2 plus 2. You'll get 3. In a similar way, for the second test case, how will you get this 3? 7 by 2, integer division. And how will you get this 4? 7 by 2 plus 1. Clear. So if it is odd, if your n is odd, you have to check whether your k should be equals to n by 2 or your k should be equals to n by 2 plus 1. N by 2 plus 1. I hope you guys are clear with the approach. Let's try to code it. Okay, let's code it. So in the first line, you'll be having t test cases. So we'll read t and also this for loop will be iterated for t times. So in each test case, you have to read nn key, no. So what the first condition we have to check? We have to check whether n is even or odd. If n is even, there will be only one possible sum we can accept, nothing but n by 2 is equals to k. If n by 2 is equals to k, then we have to print yes, else we have to print no. This is for length is even. What if the length is odd? There will be two possibilities, n by 2 and n by 2 plus 1. So if k is equals to n by 2 or k is equals to n by 2 plus 1, we have to print yes. Else we have to print no. Let's run for the sample test cases. Yes, no, yes, no, yes. It's correct. Let's submit it. Okay, it is got accepted. Hope you guys understood. Let's move to the next problem. The problem statement is there are n different types of coins. The ith type of coin is worth AI dollars, and you have BI coins of this type with you. There is an item with cost X that you would like to buy. What's the minimum number of distinct types of coins you need to use to buy it? If it's not possible to buy the item, no matter what, print -1. So if you see the note, the objective is to minimize the number of distinct types of coins used, which is not same as thing as minimizing the number of coins used. And also one more important point, it is allowed to pay more than X to buy the item. You need not to pay exactly X. So let's take an example and understand. Let's say you're having two types of coins, type 1 and type 2. Let's say the first type contains 3 coins and the second type has 2 coins. And the first type worth 10 rupees for each coin and the type 2 coin worth 15 rupees for each coin. So let's take an item X which costs 25 rupees. So now tell me, how will you buy this coin? How will you buy this item X? Using these coins with you, how will you buy this item X? So there are many possibilities, but which possibility you will choose? So let's see, if you take 3 coins from the type 1, how much money you'll get? You'll get 30 rupees. So with this 30 rupees, 3 into 10, nothing but 30 rupees. So with these 30 rupees, you can buy this X item. Is it possible? Yes. So they also mentioned that it is also allowed to pay more than X to buy the item. You need not to pay exactly X. That means you can also give 30 rupees and you can take this item. You don't need to exactly pay 25 rupees to buy this item. I hope this point is clear. Okay. What are all the other possibilities to buy this item? Can I take the second type of coin? Can I give the second type of coins? So if you give the second type, how much money you will get using the second type? 2 into 15, nothing but 30. You can also buy with this 30 rupees, you can also buy this item X. There's also one possibility. Either you can give all these 3 coins and you can take this item X, or you can give all these 2 coins and you can buy the X item. Is there any other possibilities? Yes. Let's see. So, can I do one thing? I will give 1 coin from type 1 from type 1 I'll take 1 coin. So 1 coin worth it of 10 rupees, and from type 2 I'll take 1 coin which worth it of 15 rupees. So totally how much? 10 plus 15, you'll get 25. So there is also one more possibility that you can take 1 coin from type 1 and you can take 1 coin from type 2 and you can buy this item X. So we found that 2 possibilities. So the first possibility is you can give all these 3 coins, all 3 coins of type 1, or you can give all 2 coins from type 2, or one more possibility is you can give 1 coin from type 1 and 1 coin from type 2. This is one possibility. So among these 3 possibilities, which possibility you will choose? So the problem statement is you have to minimize the number of distinct types of coins used, which is not the same thing as minimizing the number of coins used. However, here we are using 3 coins, but how many distinct types of coins we are having? 1 distinct type of coin. In the second case, we are having 2 coins, but how many distinct types of coins? 1. In third case, we are using only 2 coins, but how many distinct coins we are using? We are using 2 distinct coins. Hope you guys understand. So either you can give, so the valid answer is either you can give all the 3 coins from the type 1 or you can give all the 2 coins from the type 2. Hope the problem statement is clear. If you see the input format, the first line of input will contain a single integer t denoting the number of test cases, and each test case you'll be having the first line n and x. N is nothing but the number of elements in the A array and the B array, and x is nothing but the item which you want to buy. And the second line contains n space separated integers a1, a2 up to an, nothing but the number of value of that coins. And third line contains n space separated integers b1, b2, b3, nothing but number of coins of that type. And the output format, you have to find out the minimum number of distinct types of coins needed to buy the item. If it is not possible to buy the item, you need to print -1. So the constraints are t can go up to 1 to 10 to the power of 4, and n can go up to 10 to the power of 5, x can go up to 10 to the power of 9. And the ranges of ai is nothing but the cost of value of the coins can go up to 1 to 1000, and the number of coins can go up to 1 to 1000. Pause the video and think for all the possible solutions. How can you solve it? Okay, let's see. So if you see the sample test cases, in the first test case, let's take type 1, the size is 3. There are 3 types of coins, nothing but type 1, type 2 and type 3. So let's take A array is nothing but the cost of each type of coin. It is nothing but 1, 2 and 3. And B is nothing but the number of coins of that type. So 1, 2 and 3. So here the x value is 10. So this is a first test case. So how many minimum number of distinct types of coins required to buy the item which cost 10 rupees? Which possibility you will pick? So first, what you will do, you'll always try to take the maximum value that you can achieve, nothing but if you're having 3 coins in the type 3 and each cost 3 rupees. So totally how much money you can earn using type 3 coins? The total amount you can achieve is 9 rupees with type 3. So how much money you can earn using type 2? nothing but 2 into 2. 2 is nothing but cost of each coin, and this 2 is nothing but the total number of coins of type 2. So you'll get 4 coins. So you can earn 4 rupees from type 2. And from type 1, how much money you can earn? You'll totally get 1. So from type 1 you'll get 1 rupee, from type 2 you can get 4 rupees, and from type 3 you can get 9 rupees. So which coins you will give to buy X item? Either you can take 9, 4, nothing but you will give type 3 and type 2 coins, which will give you 13 rupees, so which is possible. And how many distinct types of coins you are using if you use type 2 and type 3? 2. And the another possibility is 9 and 1. How many distinct types of coins you are using? 2. So the answer here is 2. The answer here is 2. Again, if you take the second test case, X is same, it is 10, and type 1, type 2 and type 3. So type 1 you're having 1, 2, 3 cost of each coin of different types, and the number of coins are 1, 2 and 1. So now how much money you can earn from type 3 coin? 3 into 1, 3. How much money you can earn from type 2? You can earn 4 rupees. And how much money you can earn from type 1? You can earn 1 rupee. So if you observe here, even though if you sell all your coins of all the types, how much money you can earn? You can earn 8 rupees. Still 8 rupees is not sufficient to buy this X item. So it is not possible to buy this X item. You'll print -1. So if you take the last one, so totally we are having 5 types of coins, type 4 and type 5. X value is 100. X value is 100. And the first type, it is worth of 5, 10, 15, 20 and 25. And the total number of coins of different types are 1, 2, 3 and 4. So how much money you can earn from type 1 coins by selling all the type 1 coins? 5 rupees. From type 2 coins, 10 rupees. From type 3 coins, 30 rupees. Type 4, you can earn 60 rupees. From type 5, you can earn 100 rupees. So which type of coins you will sell to buy this X item? So obviously you'll give all the coins from type 5 so that you can earn 100 rupees where you can buy the X item. Instead of that, if you use type 2, type 3 and type 4, how many number of distinct types of coins you have to use? You have to use 3 distinct types, which is not the better answer. So we have to choose only all the coins of type 5. Got an idea how to solve this problem? Simple. So let's say instead of having 100 here, what you'll do if you're having 180? What if the item cost is 180 and the number of coins and the cost of coin is same? So what's the answer for this test case when your X is equals to 180? Simple. So first you will pick the maximum value from this values. From all the types, you will try to pick the maximum value. The maximum value is 100. So you will give all the coins of type 5 so that 100 is reduced. Still how much you required? 80. So this part is done. You have given all the coins of type 5. Still there are possibilities of giving type 1, type 2, type 3 and type 4. How much cost you want? You want still 80. So among this, which one you'll pick? You'll pick again 60 here. So if you give all the coins of type 4, so you'll subtract 60. Still how much it is required? 20. So eliminate this one. Also eliminate type 4. Now it is required 20. So if you sell all the coins of type 3, how much money you can earn? You can earn 30 rupees. So I'll give all the coins of type 3 so that I can buy this 20. So if you observe here, how many distinct types of coins we are using? We are using 3 distinct types of coins. Use it to buy the item X, which cost 180 rupees. I hope you guys understood how to solve this. Simple. So we have to find out how much money you can earn of all the types. Nothing but for type 1 you can earn 5 rupees, type 2 you can earn 10 rupees, type 3 you can earn 30, type 4 60, type 5 100. So after doing this, among this you have to pick the maximum one and you have to subtract it from the X value and you have to increment the answers. Initially answer will be 0. So when you pick type 5, you have to increment the answer by 1 and you have to subtract this 100 from X value. So later you are having 80, again you will pick 60 and you will increment the answer and you will subtract 60 from 80. You will get 20 and again you will take 30, you will increment answer. From 20 you will subtract 30. Now you got negative. When your when your X value become negative or it is equals to 0, you have to stop it. You have to break it. No need to check for type 2 and type 1. So where is your answer present? Your answer is present in the answer variable. Okay, let's try to code it. Okay, let's code it. The first line of input contains the number of test cases. So we'll read the input and iterate a for loop for t times. So for each test case, you'll be having 3 lines of input. The first line contains n and the x value, where n is nothing but the length of a array and the b array, and x is nothing but the cost of the item. And the second line contains cost of the coins. Let's take it as a array. And this is syntax how to read list of elements in Python. And for each case there are 3 lines of input, n comma x and a array and the b array. So now we have to find out how much money you can earn with the ith type of coin. So how can you get it? How much money you can earn with the ith type of coin? Simple. The number of coins of ith type into the cost of each coin. So I will generate an array C which stores how much money you can earn with the ith type of coin. So I will iterate hello for n times. So for each ith type of coin, how can you get how much money you can earn? Simple. A of I into B of I. C dot append A of I into B of I. So this C array stores the money you can earn with the ith type of coin. So when you're picking the type of coin, ith type of coin. Which type of coin you'll pick? Always you'll try to pick the coin which will give you the maximum value, nothing but the more value. So I'll try to sort it to always pick the maximum one. C dot sort, and we'll iterate a loop from n-1 index to 0 index, because we are sorting it in the ascending order, so we need to iterate from the last element from the array. So after picking the each element, we also need some more variables, nothing but answer variable. Initially it is 0. So I will check if my x value is greater than 0. That means you have to give some money to buy the x item. So how much money you'll give? You'll give x equals to x equals to x minus a of I. You'll subtract that value, and along with this, once you have subtracted a of I value, not a of I, it is c of I, because we are storing the amount of money you can earn with the ith item. So if you are spending this ith item, you will subtract that money from the x value and you will increment answer variable. That means you are giving one type of coins, all the coins to buy the x item. So you'll subtract x equals to x minus e of I and you'll increment the answer. What if your x value is less than or equals to 0? That means you don't need to give any coins. If your x is less than or equals to 0, you have to stop it. You have to break from the loop. So what condition I need to check? If you observe carefully, there is also chances that invalid case. That means there are also possibilities where you cannot buy the x item. Even though if you give all your coins, you cannot buy. How will you know that? How will you encounter that condition? How will you find that condition? One thing is, if the sum of all the elements, nothing but sum of all the elements in this C array is less than x value, it is not possible, then we'll print -1, right? But we are reducing our x value, right? When you're picking ith type of coin, we are reducing x by c of items. So what condition you'll check here? If your x value is greater than 0, what you'll print and what you'll print here? Simple. So when you will break this loop, when your x value is less than or equals to 0, you'll break the loop. That means you don't need to pay any more coins. So when your x is greater than 0, we have to print -1. That means still you need to pay some coins, but you don't have any coins. Else you have to print answers. Let's check it for the sample cases. You got 2 -1, so we know that the first test case we need to use 2 types of coins, and for the second test case we cannot buy the x item, and the fourth one you can use 25 into 4, 100, one type. Let's submit it. Yeah, it's got accepted. Hope you guys understood the solution. Moving to the next problem. The problem statement is you are given an array of length n and an integer k. A is said to be a nice array if there exists an array B of length n satisfying the following conditions. The first condition is for every index I ranging from 1 to n, B of I is equals to A of I by k, or B of I is equals to A of I by k, and B1 plus B2 plus up to so on Bn is equals to 0 is a nice array. Note that this symbol and this symbol denote the floor and ceil functions. So this symbol denotes that floor value, and this one denotes seal. First, let's see how to find out seal and floor and which value is considered as seal or floor. Let's say if you're having 3, and when you divide this 3 by 2, what you'll get? You'll get 1.5. So 1 is considered as floor value and 2 is considered as seal value for this 1.5. What if you're having 4 by 2? What is the seal and floor value? Seal value is 2 and floor value is also 2. So when you're having these decimal values, the left first integer is considered as a floor value and the right first integer is considered as a seal value. If you take a scale, if it is 0, if it is 1, 2, 3, if you are landing at some point 1.7 or 1.6, the seal value is 2. This value is called as seal for 1.6 and this value is called as floor for 1.6. Okay, nothing but the leftmost value is called as leftmost first integer is called as floor value and the rightmost first integer is called as a seal value. What if you're having minus 5 by 2? What is the seal and floor for this one? What is floor and what is seal? So when you do minus 5 by 2, you'll get 2.5. So it will be landed here. You'll get minus 2.5. So which value will be considered as seal and which value will be considered as floor? Simple. The leftmost first value will be considered as floor value, floor for minus 2.5. And what is seal value? Minus 2 is considered as seal value for minus 2.5. Always, whenever you are landed any number, the leftmost first integer is called as the floor value and the rightmost first integer is called as the seal value. I hope this point is clear. Okay, coming to the problem statement, you'll be given an array. So from that array, you have to perform division operation with respect to each and every element in the array. If you take let's take a small example. Let's say your array having 4 minus 3 and 2 and minus 4. Let's say this is your array. For each element in the array, let us also take k value. Let us take k equals to 2. So for each element in the array, you have to find out the floor value, you have to find out the seal value. You have to find out the floor value and seal value. So with respect to this, what's the floor value for 4? When you divide with 2, you'll get 2. So the floor value will be 2. What's the seal value? Okay, let's take it here. Let's say this is floor, this is seal. So what's the floor for 4 by 2? It is 2. What is the seal for 4 by 2? It is 2. So when you divide this minus 3 with k, nothing but 2. What's the floor? Minus 3 by 2 is nothing but minus 1.5. So floor is nothing but minus 2 and seal is minus 1. And when you divide this 2 with 2, you'll get 1. So floor is 1 and the seal is 1. When you divide this minus 4 with 2, you'll get floor as minus 2 and seal as minus 2. So after finding this floor and seal for each element in the array, they are asking that you have to pick any one of the element from the seal or floor. So for each element, from the element at 0 index, 1 index, 2 index, and 3 index. So with respect to each index, either you can pick floor value or you can pick seal value. You cannot take both the values. So you have to take the values such a way that sum of all the elements should be equals to 0. Sum of all the elements should be equals to 0. So can we make the sum is equal to 0 by picking any one of the element from the floor and seal? Yes. So from 0 index element, it doesn't matter which element you will pick because both floor and seal is equals to 2. Now, from floor and seal, which one you'll pick? I'll pick -1. I'll pick seal value here. And here, among this, which one you'll pick? Both are same, so I'll pick 1. And here, both are same, I'll take -2. So if you add, this is nothing but B0, B1, B2, and B3. So where if you add all these elements, the sum will be equals to 0. So the output is yes here. So you have to print the output as yes. So if you see the input format, the first line of input will contain integer t denoting the number of test cases. Each test case consists of 2 lines of input. The first line of each test case contains 2 space separated integers n and k. The length of array A and the division parameter nothing but k. The second line contains n space separated integers a1, a2 up to an, the elements of the array. So the output format is, for each test case output on a new line, a single string denoting the answer yes if A is a nice array and no otherwise without quotes. So you have to check whether you can able to construct this B array or not, such a way that if you add all these elements in the B array, it should be equal to 0. Then we call this given array as nice array. Then we call this given array as nice array. So if you see the constraints, t can go up to 10 to the power of 5. The size of the array is 10 to the power of 5. And the k size can go up to 1 to 10 to the power of 9. Array elements are ranging from -10 to the power of 9 to +10 to the power of 9. So I hope the problem statement is clear. Pause the video and think for all the possible solutions. Let's take the first sample test case. You're having 2, 4, -2 and -4. So you're having 2, 4, -2 and -4. So where the k value is 2. So what is the floor value for 2? 2 by 2 you'll get 1. Floor value is 1 and the seal value is 1. So I'm writing all the floor values on the top and seal values on the bottom for each element. For 4, the floor value will be 4 by 2. You'll get 2 and the seal value is 2. And here it is -1. Here it is -1. You'll get -2 and -2. So here you need to pick any one of the element from seal and floor for each element, such a way that the sum should be equal to 0. So which sequence you will pick? Either you will take 1, 2, -1 and -2. If you add all these elements, you'll get 0. Otherwise, you can take 1, 2 and you can take -1 and -2 here. You can take any elements. Either you can pick the floor value or you can pick the seal value of a given number. So let's take one more example for better understanding. Let's say if you're having -5, 5 and 3. Let's say your k is So now tell me, what are all the ceil values and the floor values? So for -5, the floor value is -5 by 2, you'll get -2, -2.5. But the floor value is left element -3 and the ceil is -2. For 5, the ceil value is 2 and the floor value is, floor value is 2 and the ceil value is 3. For 3, floor value is 3 by 2, you'll get 1.5, 1, and ceil value is 2. So now, is it a nice array or not? Is it a nice array or not? So which sequence you'll pick? You'll take -3 and you'll take 2 and you'll take 1, which will give you the sum is equals to 0. But how will you know that you need to pick only this -3, 2 and 1? How will you know that? You need to take only the floor values. So to solve this problem, what is a very brute force approach? The brute force approach is you have to generate all the possible B arrays. You have to generate all the possible B arrays and you have to check whether the sum is equal to 0 or not. If any one of the possibilities sum is equal to 0, then you can print yes, else we need to print no. So for this given array, we have generated the floor values and we have generated the ceil values. Can you tell me how many possible B values we can generate? So the first possibility is we can take all the floor values. Nothing but you can take -3, 2 and 1. And the second possibility, you can take -3, 2 and you can take 1 from the C. So -3, 2 and 2. Another possibility, -3, you can take -3, 3 and 1. You'll get -3, 3 and 1. And -3, 3 and 2, -2, 2, 1, -2, 2, 2 and -2, 3 and 2. So totally how many we got? And -2, 3, 1. So -2, 3 and 1. So if you observe this, if you are having an array of size 3 and after generating this floor value and ceil values for each element in the array, how many possible B arrays we can generate? If it is n, how many we got here? Here it is 8. So if you are having n equals to 3, the total number of possible B arrays are 2 power n. It is equals to 2 power n. What if your array size is n equals to 4? Then you'll get 2 power 4. Nothing but 16 possibilities. So if you observe here, simple. The simple equation is for each element, either you can include or not include. So there are 2 ways for the first element, there are 2 ways for the second element, and 2 ways for the third element. So 2 into 2 into 2, you'll get 8 possibilities. There are totally 8 possibilities. So if you solve this problem using backtracking, simple, or you can use bit masking, simple. The approach is either you can include this element or you can include this element. So after generating all the possibilities, you have to check whether sum is equal to 0 or not. If sum is equal to 0, then print 0. So if we use backtracking, the time complexity will be 2 power n of generating all the possibilities. 2 power n. So if you see the constraints, what could be the n value in the worst case? T is the time complexity we got is 2 power n. In the worst case, n can go up to 10 to the power of 5. So if you substitute 2 power 10 power 5, you know how much the value is? It is very large. If you consider a small value, 2 power 30, how much the value is? With respect to powers of 10, you'll get 10 to the power of 9 iterations. If you're having the n value is 30, you're getting 10 to the power of 9 iterations. Can you able to solve a problem if it is going up to 10 to the power of 9 iterations? No. For any problem, we need to complete within less than or equals to 10 to the power of 8 iterations. So definitely we'll get time limit exceeded if we follow this backtracking approach. So we understood that this approach is a correct approach, but it will not work for these constraints. It will not work for the given constraints. So can we do any optimizations here? Can we do any optimizations? There are small observations. If you observe carefully, you'll get it. Let's see. Let's take one more example and understood. Let's say if you're having 4 minus 2, 2 minus 6 and 2. For this array, let's try to find out floor and ceil values where k equals to 2. What's the floor value? 2. Ceil value 2. Floor value minus 1. Ceil value minus 1. Floor value 1. Ceil value 1. Floor value minus 3. Ceil value minus 3. Floor value 1 and ceil value 1. So if you observe here, if the element is perfectly divisible with k, then ceil and floor value will be same. So what's the minimum sum you can achieve here? The minimum possible sum is 0 here, and here it is also 0. Hope it is clear. We are getting zeros and zeros. Let's say k equals to 2. So this is the floor value and this is a ceil value. Floor and the ceil values. So now let's do small changes and observe that how it is varying with respect to this sum. It is 0 and it is also 0. What I'll do is, I have 2 here, so I will make this to 3. I'll make this to 3. And also I'll make this minus 1 to minus 2 to minus 1. So now let's try to find out this floor ceil and let's try to find out floor ceil. So here what is a floor? Minus 1 by 2, you'll get minus 0.5. So floor is 0. And what about ceil here? You'll get minus 1. Now, if you take 3, what's the floor here? Okay, this is floor and this is ceil. And what's the floor here? Because always the floor will be the minimum value. And for 3, the floor is 3 by 2, you'll get 1. And the ceil is 2 here. So now what's the minimum possible sum here? If you do 2 minus 1 plus 1 will get cancelled. and you'll be having 3 and minus 3, you'll get 0 here. And what's the maximum possible sum? You'll get minus 3, all the sum will become 0, and you'll get 2 here. You got 2. So observe carefully here. Observe carefully here. So how many values I have changed here? So previously it was 2, I have changed it to 3, and here previously it was minus 2 and I have changed it to minus 1. So here there are two possibilities. Either you can take minus 1 or you can take 0. And here either you can take 1 or you can take 2 here. Okay, so what is a very minimum sum possible? That is 0. Forget about making everything into 0. Just see that what is the minimum possible sum and what is the maximum possible sum we can achieve. So from the given values, what does this flow denotes? The minimum values for all the elements. The minimum values for all the elements. So 2 minus 1, 1 minus 3 and 1 denotes the minimum values. So when you are adding all these minimum values, this is also one possibility. When you pick this possibility, you are getting the sum as 0. You are getting the sum as 0. Is there any possibility that to get the sum as minus 1, minus 2, minus 3? Is it possible? It is not possible. You can take any possibility, minus 1, minus 2, minus 3 and so on. Any negative sum is not possible. If you take 2, minus 1, 1, minus 3 or 1, you take any possibility, the sum will not be less than 0. So the minimum possible sum is 0. So in the same way, when you take the sum of all the CL values, when you take the sum of all the CL values, what's the sum here? You got 2. You got 2. So is there any possibility of generating a B array such a way that the sum is greater than 2? The sum is greater than 2. Is it possible? No. You can take any possibility. You will take 2 here, 0 here, 1 here, and you can take minus 3 and you can take 2. Is there any chances that the sum is greater than 2? It is not possible. So the maximum possible sum is 2. So we understood that after generating this floor array and generating this CL array, we found out the minimum possible sum and we have found out the maximum possible sum. So we need to clarify a few more things. Is it possible to generate a B array whose sum is equals to 1? Is it possible to generate a B array such that whose sum is equals to 1? Let's see. So I'll take 2 here. Simple. So when you take all these elements, the sum is 2. So we have to decrease the sum by 1. So instead of taking 0 here, what I need to take? I will take minus 1. I will take minus 1. So if you take this possibility of B array, then your sum will be equals to 1. So can I say that after generating this floor array and after generating this CL array and finding the floor sum and the CL sum, so the floor sum is 0, let's say x, and the CL sum is y. Can I say that we can generate the B array with the sums lies between x less than or equals to y, where the sum is less than or equals to sum of B array which is less than or equals to y. Can I conclude this statement? if this is your 0 value, if this is your 2 here, I can generate the B array such that its sum can be 0, its sum can be 1, its sum can be 2. Let's say if your CL sum is 4, can I say that I can generate a B array where its sum can be 0, its sum can be 1, its sum can be 2, its sum can be 3, and sum can be 4? Yes or no? It is possible. Let's take one more example and check it. Let's say if you're having minus 5, minus 3, 4, and minus 1 and 2. So if you take this, what's the minimum possible sum you can achieve? Sum of all the floor values. So try to find out the floor values here. So the floor for minus 5 is minus 3 and minus 2. CL value is minus 2. For minus 3, floor value is minus 2 and the CL value is minus 1. And for 2, for 4, the floor value is where k equals to 2 and 2. For minus 1, the floor value is minus 1 and the CL value is 0. And for 2, the floor value is 1 and the CL value is 1. So what's the minimum possible sum you can achieve? Minus 3 you'll get minus 3 minus 2, this will become 0 and this will become 0, so you'll get minus 3 here. So what is the maximum sum possible? Minus 2 plus 2, 0, minus 1 plus 1, 0, and the maximum sum possible is 0. So we got minus 3 and 0. So now tell me, we understood that minus 4, minus 5, minus 6 sums are not possible, and 1, 2, 3, 4, 5, 6 up to so on, this positive value sum is not possible with this floor and CL values. Now check it that is it possible to generate a B array whose sum is equals to minus 2? Check if it is possible to generate a B array whose sum is equals to minus 1. Is it possible? Obviously yes, because if you consider this minimum values, your sum is minus 3. You got the sum as minus 3. So to get minus 2, to get the sum as minus 2, you have to increment only plus 1. So we definitely know that the difference between the floor value and the difference between the CL value of a given element is not more than 1. Is not more than 1. So instead of taking minus 3 here, I will take minus 2 and I will take minus 2 here, 2, minus 1 and 2. So what is sum now? If you follow this sequence, what's the possible sum? You'll get minus 2. Is minus 1 possible? Is minus 1 possible? Let's see. So instead of taking minus 1 here, you have to take 0. So if you follow this sequence, you'll get the sum is equals to minus 1. So we can conclude that the floor sum, after finding this floor sum and after finding the CL sum, it is possible to generate all the possible sums from x to y. It is possible to generate all the sums from x to y. But what is our problem statement? Our problem statement is we need to check that our sum should be equals to 0 or not. So how can we check it? Simple. So we need to check whether this x is less than or equals to 0 and y is less than or equals to 0. So if x is minus 2 and y is 3, So -2 sum is possible, -1 sum is possible, 0 is possible, 1 is possible, 2 is possible, and 3 is possible. So our required sum is 0. So 0 is definitely possible. We can print yes. We can print yes. So we have to check for this condition. We have to find out floor values and add it to the x value, and we need to find out all the ceil values and add it to the y. And finally we need to check whether this condition is true or not. So let's write the code for this. Okay, let's write the code for it. First we'll read the number of test cases. Iterating the loop for t times. So for each test case, we are having two lines of input. The first line contains n and k. And second line contains array elements. Okay, so basically we need to find out the floor sum and we need to find out the ceil sum. So let's declare two variables. Floor sum is equal to 0 and ceil sum is equals to 0. And for each element in the array, so if it is even number, if a of I, not even, if it is divisible by k, then ceil and floor will be the same. So I will add floor sum is equals to a of I by k, and ceil sum is equals to a of I by k if it is a divisible by k. If it is not divisible by k, then the floor and ceil values will be different. So the floor sum is nothing but a of I by k. Simple. If you assume that this is 5 and this is 2, you'll get 5 by 2 is nothing but integer division, you'll get 2. This is floor. Then what about ceil? Whatever the floor you got here, you have to do plus 1. You have to do plus 1. So finally, what condition you need to check? If floor sum is less than or equal to 0, and 0 is less than or equals to ceil sum, then we have to print yes, else we need to print no. Let's run the sample test cases. A of I by k, it is capital K. Okay, we got yes, yes, no, yes. Let's submit it. It is got accepted. Okay, so what's the time complexity here? This will iterate for t times, and we are iterating only one for loop which will iterate for n times, and n over all the test case will be 2 into 10 to the power of 5. So the time complexity of our code is big O of m, which is not exceeding 10 to the power of 8 iterations. So it can go up to 2 into 10 to the power of 5. Okay, and one more point here. So if you are using C++ or Java, you have to check one more condition here, because when you do a of I by k, let's take a of I is -5 and k is 2. What do you guys think the floor will be? The floor will be -3 and the ceil will be -2. But when you do this a of I -5 by k, nothing but 2, you'll get floor sum as -2 and you'll get ceil sum as -3 in C++ and Java. So by default in Python, when you do this a of I by k, if it is negative number, it will take the floor value. So that's the reason I'm not checking the condition that if the element is positive or negative. So if the element is negative, that means if a of I is negative number, then you have to add this number to floor sum and you have to add this number to ceil sum. Okay, cool. I hope everyone are clear with this problem. If you like this video, please consider liking it and share it with your friends, and also subscribe to our Smart Interviews YouTube channel for more such content. Thank you.